Hi, Mohamed. So I'll introduce Mohamed, and I'll let you say a few words about yourself as well. So you are a senior enterprise architect at DevTech. You've got spectacular credentials, and it seems like you have been speaking a lot at conferences. So let you introduce yourself, and then you can probably kick off your talk on effective rest.
Yeah. First of all, thank you for having me. It's my pleasure to present at Geekle, and it's first time, but I hope we are going to do it more and more, and even which would be more better to have face-to-face. So I will
eventually.
Yes, I hope so. So I try to jump into my presentation, share my deck, because I have a lot to share, but we have a limited time. So I will introduce myself during my presentation. So let me try to share. And I am going to hide myself in my presentation so the audience can focus more on presentation and just listen to me, also to reduce the bandwidth usage.
Sounds good.
Okay, just one sec. Let me try to see this one.
Right, let's see. And also, if you're experiencing issues with the stream or the audio, do let me know in the chat. We are monitoring it, and we're in the background fixing things. And then I can also like pause a speaker or something to fix the issues if they become a problem. So we are just waiting for Mohamed to come back on the stream.
Yeah, I'm sorry, it just crashed.
No problem.
Sorry for this, just one sec. Get frozen.
She's going to come on. And yeah, I guess in the meantime, I can also let you all know that you should subscribe to the Geekle official page on Facebook and Twitter if you want to be aware of the next events. It's kind of the time for socially distanced events such as this one, because unfortunately we can't really have conferences. But yeah, many events are coming up, all online.
Takes some time to load. I don't know why.
Yep. I mean, that's always the thing with presentations, I feel, in technology. It always works until it doesn't.
Everything was open and nice and ready. And just when I tried to share, the Chrome crashed down.
It's the demo curse. Right.
There's an issue.
I guess in the meantime, where are you presenting from?
I am now in Belgrade, Serbia.
Nice. Is it a full lockdown or are things back to normal?
You know, it was full lockdown and we get back to normal, and then now introduce some new measurement because the number of cases keep raised again. So it's like the second wave, you know.
Yeah.
So it was really.
Yeah, it's always.
Yes, it's tough a little bit. Let's
see.
Let me try my luck now. Which one? Experiments. Okay. Let's see sharing again.
Let's see if it arrives.
I hope so.
I think I see something.
You can see my
there you go. All right, I think we're on. Right. Floor is yours.
Let me check what you can see. Because I have to check the screen. There's something. Let me, just because the size does not match the screen size of your screen, I'm going to just
People in the chat are just saying hello, Mohamed.
Yeah. I'm sorry for this, but
No problem at all.
I used StreamYard before, but there is always something need to happen.
Okay, I think we're good. I can see the thing on the stream.
It's still also this problem. Okay, the last time to share another screen. I'm using this one. I hope you can see this is normal.
Yeah, back.
Yeah,
Yeah, it looks normal.
Yeah, okay.
Looks
This
good.
is what I
Perfect.
want. Okay, can you hear me clearly, right? Can you hear me or sound?
Chat. Yeah, people are saying they can hear you and see you, so we're good. Do write in the chat if there are issues at any moment. And
Okay.
with this can go.
So I'm sorry for taking some time in order to just adjust this presentation for you guys, and I'm happy to present for you this presentation. And my name is Mohamed Taman, and I'm working as Senior Enterprise Architect for DevTech, and also I'm owner and founder of SiriusX Innovations, doing consultancy, software development, and book publishing and article publishing, and this kind of software consultancy and workshops. So I'm Java champion and Oracle groundbreaker ambassador. I'm a GCP member. I love to speak. My language is official after English and Arabic is Java. I'm author and international speaker. So if you'd like to just catch me, ask me any questions, anything, you can catch me on my social media, especially all my proof of concept projects. You will find it on GitHub on this link. I'm socially LinkedIn for professional. Facebook, you'll find me easily, and also at my Twitter handle, because I'm living at Twitter. So this is my Twitter handler. You can take it at _Taman. And now let's jump into what we are going to have in our presentation. So here is our agenda. And this is, we are going to talk about how to effectively design RESTful API. So we will start with a simple overview of what it takes actually to add an effective API to your system, whenever you are, which system you are developing with, either it's greenfield, brownfield, or legacy system. And then we will move on to defining who will benefit from your API and what they will hope to accomplish with it. And we call these people, those are the participants of the system, which is more important to know about them in order to develop a proper and effective API that will be resilient for business and the customer as well. And then we will paper test our API to make sure it makes sense, because this is very important. And once we have our APIs modeled, we will deep dive into some HTTP concepts, which is just enough for our API design. We are not going to deep dive. And risk constraint that help determine our design. Finally, we will learn how good APIs is like, for example, when you choose your adventure book. This is very important, as we will talk about links relationship, how we can design our systems, and also, most importantly, is how to explore an API even without documentation. So how we can design an API that's self-descriptive, which is self-documented. So let's get down to the business and explore some design concepts of the APIs. So before we jump in, I would like to tell you about the approaches when we are dealing with a system and we would like to add an API. So because we have different systems, you might join a team or start a project, which is it's a legacy system, or you're just lucky enough to start a project from scratch, or you have already just a project and you would like to take a business benefit and introduce new channels by integration with different systems, integration with mobile, integration with IoT. So you have to have an API which is REST interface to standardize the call, and this REST API will be applicable for all the kind of integration from different channels. But before we just deep dive, I would like to speak about the design itself and the concept of the design. So when we understand what is design is, will help us how we can design not just our API, designing of our software, methods, classes, architecture, any kind of design. The most important when you would like to design something, it's just you have to put in your mind, design is not an easy, especially if you like to design for simplicity. Whenever you go for simple, means you're going to be hard in order to achieve simple stuff, because it's very easy to have a spaghetti and it's very easy to have a lot of and bunch of APIs just to serve your client, and your client will cry in order to use all of these APIs. So there's 4 questions I during my life experience, just is on 4 questions I just asked myself, okay, what functionality I would like to expose? Then this is, I get it from the business perspective, from the requirements and everything. Then I try to analyze the requirement in order to know what is the functionality to expose. And most importantly is how to expose it. Because as I told you, we can have like 12 API, and if we do a more analysis and we care about how to introduce a simple API usage, because this will increase the business integration with your API, is how to expose it in a simple way. And how best way to expose it. This is the second. This is now we are improving. And then we do some tweaking, adjustment, also to reduce the names, to reduce the requirement for the API. So if I require 4 fields, why not try to reduce it to 2 fields and trying to get more information behind the back? So it will become more easier to integrate with. But yes, from our perspective, from the design, it would be hard because we need to make it simple, but it will pay back when it comes to business. So those 4 questions are very important. And also you have to understand there is only 2 hard things in computer science. Cache and validation, and we agree on this, and also naming things. Naming, whenever you try to name, because naming things correctly means self-documenting. And when we do testing, when we do, for example, when we write test names, function names, trying to remove classes names, interfaces, API, the URLs, and the combination of URL names, verbs we put alongside, so we understand from just looking to the API what it's supposed to do. This is very important. And we will see how we can name things when it's related to API. But because I'm talking now generally, so you have to understand how this could be applied to any kind of software areas, like when I design my classes, design my framework, design database, whenever it applies to database. So for example, we have in design something called affordance. What is affordance? This is a term we got from human-computer interaction, which talk about design. So design of the hard disk, design of the computer itself, design of your cell phone, how it should be really just enough design that make you easily use this device or thing that you are trying to produce. So affordance is something which allow you to perform an action or accomplish a goal. For example, if we take in general life, if we have a door locker like this one, what is the affordance of this? It's just to turn it right or left in order to open or close the door. And that's enough. Why it's rounded? So there is design issue here. Round because any hand can grab it. It's easy to catch. It doesn't harm my hand. And this is also design consideration, also for light switchers. So it just affordance here is just to switch on and switch off the light. This is very important. You can read more about this kind of affordance in terms of design when it comes to my amenities. And affordance in practices. So what does it mean? It doesn't mean what the API allows you to do. So what API makes it easy to do this functionality and what the user wants to accomplish. Because I could design and respond to the functionality with something that finally users don't want to accomplish, because I have too much APIs, or even I do the functionality that is I understood in a different way. So I have to make sure that, yes, I know the functionality, and make sure that this is the functionality should be done in this way in order to satisfy the customer need. So I get back to the customer, I try to explain my solution, and you need to do this in order just to prove and make sure that what I'm exposing is actually what the customer and the market needs from my side. So let's talk about coffee, because we are developers, architects, whatever your position is. We love coffee. So I will give you one example before we deep dive. So let's talk about coffee cups. So if we have a coffee like this, why we have a handle here, like coffee cup handle? So why design it like this? Because handles are great in order, it's designed for holding the content, especially when it becomes hot, in order to avoid burning my hand. And also we can use it in the same way for holding the cups, and we can use it for other things like holding cups in the kitchen holder, or just I can grab many cups with this. It's not that small, it's not that big, and it should be adequate for any hand to grab. So this is the concept of design. So this is just I would like to introduce for you in terms of design, because we are going to use this concept from now until the end of this course presentation. So we are easily engage this concept inside our AP design. Let's get back in what I have said at the beginning, how we can add an API to our systems. So if we have a bolt-on strategy, which is brownfield, which means if you have already project and it's running for a while, and then you are working with a banking system and it works, and yes, it's digitalized, it's not that old one or legacy, but you would like to introduce a new mobile interface, a new web interface, and you would like to integrate with different banking systems, you would like to integrate with different vendors in order for login or using your API for credit cards. So now you have many channels. So in order to standardize the same integration point of exposing the functionality, it's much way better to introduce it as a RESTful API. So in this way, we have a brute force approach. Yes, it's generally the fastest way to get something useful, because your business is running, and just you wrap your business by introducing new APIs. But here also takes advantage of existing code and system because it's up and running. But problems sometimes, if you have a bug in the system, these bugs will leak through the API easily. So this is the fastest way to get something from your system. And on the other hand, if you're starting a new project, which we call the greenfield, so this is much more. But when it comes to design, we design first the APIs. Then behind the API, we design the back end and the functionality. So we start with the contract. Okay, this is the functionality we need to expose first, and this is what we are going to do here during this presentation. So, and we call it either API first or mobile first mindset, and definitely takes advantage of any new technologies. You have the freedom to use the technologies, and also to reinvigorate your team to use this technology and start to dig deep to be responsible about their piece of code and using different kind of technology. And we have the possibility to leverage the stack with the latest. And it's always possible to drive business very quickly and easily, because you have MVP in mind, and then you try to get the business for what is required to just be in the market as early as possible with your most valuable product features. And we have the most hardest one, but this is sometimes we have legacy systems. I have been working for a project that integrate with pension, tax, customs, and Egyptian government before I leave, and it was like a mainframes, COBOL systems, and it was very hard to integrate. But We have to, and then we would like to integrate it with payment hubs. We would like to integrate it with ATM machines, and all of this communicating through HTTP, but COBOL system and mainframe does not understand this kind of API. So we have to build above these COBOL interfaces something that can take the functionality and expose it in terms of HTTP and only available at that time to SOUP based. And then we have like adapter that converts SOUP into REST API in order for all the integration with different systems. So do we allow to have reporting systems, pension information or taxation with different kind of systems in the country. So this is how it works. And in this, we're trying to create a facade surrounding, because it's totally different. You have to have a facade and wrapping the current business which is running for a long time, because you cannot reintroduce it again. It's running. And when you go for legacy systems like banking, and this system, they will definitely tell you, we are not going to redevelop again, definitely, because we are stable and it will require too much money. You have to find a way to expose our business outside. So we call it facade for this reason. So we wrap existing logic, replace as we go, and also it's idle for legacy system as an application, as it's always functional. And this is how you can exchange. The main problem we faced in this way is the mindset, because when you work with COBOL or legacy system, the people who is working in these systems have a different mindset from your way of exposing the functionality as in modern languages and modern web, because they never have something like web. They always procedural language. It's not object-oriented totally, so you have to take care of this mindset, because it could make it challenging to introduce the new functionality and what you ask them to do for you in order for to integrate well to expose this functionality. So summarizing this, we have 3 approaches while you can take leverage of this, which is you can have brownfield systems, you can have greenfield system, definitely, and lastly, we can have legacy system, and all of them we can take advantage of the current business and introduce the business functionality to the market. So modeling. Now, imagine that we have a system and we would like to introduce our API. Here, we would like to model our system without writing a single code. And we should determine the final URLs, the verbs, either is get, post, and the payload, and what is the parameters that we need in order to have this in paper-based or documented, whatever tool that you are using. And then you just give this for different integrated parties that would like to integrate with you. So you develop the contract, and then you have isolation and have the freedom. You don't have dependency. It's non-dependent, because you have a contract and each one should apply and accept this contract in order to develop their interfaces. So for QA, it will be very easy to start modeling their testing for quality assurance. Your QC team start to develop their quality controls. Your mobile team start to build their systems, and they have all the information. And you as a backend would like to start developing the functionality to expose, and then it will come just to integration. And whenever you have something that you introduced new or something different, or you during your design you find something new, you just should update your documentation and notify the parties. So the changes here will be like 10% or 5% overhead, instead of just trying to develop the function, then expose. Then we have like 90% trying to integrate, which is almost failed because nobody knows what is it. Or you are going to be delayed to the market because you start to develop first, then you expose, take more time. So it's first thing is model your API, develop your API, give the contract for the other parties, start all of you on parallel developing what it takes in order to consume and expose the functionality. So you have time, and you best make of your time. So let's see how we can model these APIs. So we have tips. And I would like to lay 3 simple rules here for you. Don't worry about the tool. It doesn't matter which tool. Use whenever it make it easy for you to document and model. Sometimes we are stick to the tools and we take too much time and make it complex. Sometimes I use the whiteboard, I'm using sticky notes, I'm using my Word document, I'm using any kind of tool that make it easy for me to lay out and model my API. So this is very important. The second rule is you have to be consistent process, because if you define a consistent process and you go over this process again, you are making sure that you don't miss any functionality. And at the same time, whenever you have, for example, you developed something or you introduce something new, you have to make sure for the second process that you are updating your documentation. The third process, I publish this for the third party. The fourth thing, that I don't miss any functionality, or the functionality is complete by validating it. So this is how you should be consistent, and you will not forget about, propagating the change for different places. So have it written, and I will show you my process that I follow in order to make sure always that I don't miss anything. And finally, which is also one of the most important in this, it doesn't count unless it's written down. So if you don't write down every single thing, like your process, your API documentation, your payload, or whatever it is, you will miss a lot, and also you will forget. So if you went to a meeting and discussing something, either you have a friend of you or one of your colleagues documenting, or yourself, or at least make a record of the conversation. I do this when I do pre-sales activities to get opportunity. I'm talking to the client, so I just excuse them that I'm going to record the session in order to always get back to this session to understand really what's happening and to make sure that I didn't miss anything. Or sometimes I write down. The same when I do interviews, I write down all the feedback, so I have always the proper answers for why I would like to continue with this candidate or not to continue, or in business or meetings or whatever it is. So it's very important, very, very important to write down everything. So documenting everything, and you can deprioritize everything later. Whenever you document, you have the full information, and then you lay down at your office or at your desk. You start to read all the documentation you have written. Make prioritization. I would like to do this first. I need to send this email for the team to update them. I would like to have a meeting with my team in order to tell them about the new functionality and everything. So this is very important. The second thing that we talked about is I have a functionality, but I have to ask a question. If you are a senior developer or architect or whatever it is, the same like the questions when you ask for non-functional requirement, like security, like how many participants should make use of this API. And also, here also, when we design functionality, we should understand the persona of each user who is using our system. We should identify anyone can use your system, because this will affect the way you are developing. Because sometimes when you develop, normally you focus just about the customer, while in your company you could have operation team, you could have IT team, you could have a call center team, which is easily make use of your system to solve their problems without getting back to the developers and make it heavy. So if you have an issue, imagine that if you have an issue that that call center or operation team could solve, and they doesn't get back to you, it will give your time. But imagine you don't design and putting in mind all your participants. The big problem is whenever there is an issue, they will kick your back, because you have to solve this. You are the developer, so they don't have the tools. So put this in your mind. This is very important. It's not about just the customer or the end user. It's about who's going to maintain this software, who could access. If you are developing something like Amazon website, definitely you have call center, and you have these people should be able to cancel and request your orders, not about you or the customer only. So they have to have access about different parties. So this is very important process. In this way, you are going to really identify your API correctly and how you can expose it. This is what I mean, how to expose your API. Yes, I know the functionality, but how and for whom? So for each participant, we need to capture the following. Who they are, as I told you, is they external or internal to organization? This is for security considerations and for integration point of view, because sometimes I cannot expose all my APIs externally and even internally, because sometimes it could be for admin, it could be for just users, so nobody mess up with our API. And we need to have a short description who they are in order to understand, for example, their persona about the domain. So we capture some wording so we can expose this wording for them. So let's make it easy. If you are working for financial domain, they have an account. It's totally different meaning than when you're working for example, for retail system, because account there means customer and account here means financial. So it's totally different, and you have to take care of this. This will affect your design. And then let's take example again about coffee shop, in this time not coffee cup. And first, I would like to identify who are our participants. So we have the patron, which is you. I'm talking from the perspective of the coffee shop, because I told you we should talk. If I'm designing for a coffee shop, I have to speak their language. So we have the patron, we have the cashier, we have the barista who's doing the coffee for us behind the machines, and definitely we have different customers, which is patrons like us. So what to do? Now I know each of them. So let's see how the functionality should run. So if you would like to identify the activities and breaking them into steps, this is the second. So I have the functionality, I asked about the participants, and then I would like to break down the activities to see how they can interact. So if we will have version 1. So what is activities from ordering a cup of coffee, and then to the end when I get this cup of coffee. Nice cup. I'm not coffee. Just simply you place an order and you wait for an order and then you receive the order. It's very simple, right? But this is not complete. Why? Not complete because it just describes you. So let's try again in order, because we have 4 participants and we just described 1. And in this way, we are going to expose API that serve only the patron. So what happens behind, because we have machines, we have inventory, we have a lot of stuff that we should take care of. So if we revisit again, we should do that. The patron, which is you, creates an order with cashier. So we should see who interacts with whom in the system. And then the cashier passes the order to the barista, definitely. So if there is a queue or like announcement system or something they agreed on, so you have to develop this in the system. And then the barista acknowledges the order. He knows about the order and add it to the queue because there is a queue. This is very important. And then orders are processed, inventory and machines are tracked because I have to take care of the quantities and the things that I'm serving. And then see, we have now inventory and machines because we're trying to see what will happen behind. And also as orders are ready, they are announced and delivered to the customer. And finally, the customer receives their order. This is complete. If you get back to your participant and trying to map it here, you will find that you use patron, you have the cashier, what the cashier should do and interact with what. Barista, what is the functionality of the barista in the system and who, which part of the system should be affected when barista start to do the coffee cup for us, and from where the customer will receive the order. This is very important. This is how a consistent process about, we should know about, we have the functionality and we should know about the customers or participant, and then we broke down the activities in order to identify who is going to do what. Okay, let's now take an example, real example, small one, and I will explain all this process until we get the final URL and how you can do it without any kind of tool, just paper-based. So we love to always have an example about order booking online. I'm just not speaking about all the systems. I have a cart and the interaction between the customer and this kind of book online by ordering a book, and that's it, or check out the cart. I don't care about the payment system. I don't care about this because we have short times. So let's do. First, as I told you, who are our participants? We have system admins. Yes, they could maintain. We don't know yet, but we have system admins in order to maintain our system or something. Yes, we have developers. They could feed the system or something. We have the customer, and definitely we have the customer support. So let's see. Sometimes we could identify the participant, and when we map for the activities, we found like there is two customers does not have any functionality here, so you can drop them. But it's much way better to identify all the potential and initial customer. Then when you map the activity, you could drop, but it's much way better than missing one of the customer or participant, because it will affect your way of developing the API. After identifying this, let's see our functionality and what is activities. And for short here, this is our activity. So we place an order. So placing an order could be done by customer only. We know this. Look up an order status. Yes, it could be done by customer support and customer. Cancel an order, adding item. This is the functionality. I adjust, okay, the customer told me I need this functionality in my system. So I would like to place an order, look up for an order status, cancel an order, add item to cart, remove items from cart, clear the cart to check out the process. We are going to see how to map these activities as we did before in the first example about the coffee cups and coffee shop. But here it will be more detailed as really we are developing a real API. So now this is the other process. We have the activities, we have the participants. Now we need to create and group API methods. We're trying to group for which functionality, the life cycle of this API, grouping. So what does it mean? Let's see how we can do this. And this is my process that I told you, consistent process. First step, identify participants, and then identify activities. And we are tweaking who using what. Then I start to write down this participant do this in the system, and this system is going to be affected. Then I will understand the relationship. Then I mapped everything. I drop the participant that does not have any functionality, and also I'm making sure that I covered all the activity. And everyone has a function to run this activity. Then break it into steps from the activities, because I need to make it small steps. It's not complicated, because when we develop REST API, one of the rules and constraint of API, it should be stateless, and it shouldn't be run in order. I can run it in different order. So I'm trying to break it down to the smallest functionality possible and make it coherent. And then we are, after breaking, identifying activity and participant, we are creating the API definition. Now we are going to create the URLs, putting the get, post, update, delete, whenever it is relevant for the definition and the functionality, identify the payload, and finally validate your API. Those are the main 5 steps that you need to, and then you see that you can get back to identify, I missed one participant or activity, or I didn't break it very well into smaller steps, or I did some wrong API definition. Then this is how validation is very important, like testing, but we didn't actually test using tools. And let's see how we can do this. Reviewing the last thing. So we have these participants and we have this functionality. I start to create an API definition, grouping and creating API definition, the 4th step. So how we do this? First, we identify the resources. What is the resources? Is the nouns. The nouns that are doing the activities, the life cycle of the system run around this. So for example, we have item resource. So what can we do with item? Because we place item, we add item, we do something with item. So item resource, we can list items, view items, search items, add and edit items. This is the grouping for each resource or API definition. This is what I call it. API definition, which is the first resource item, I do this functionality. What is the next resource? Cart. The cart is another resource, and why? Because we can add item to cart, remove items, clear cart, view cart, check out. And then what's next? We have orders. We need to list order for customer, obtain order status, and cancel order. And lastly, we have the customer, because we need to view the customer, search about the customer, add or edit customers. So this is how we identify the resource, grouping the life cycle for this, the API definition functionality around these resources, and then how we can define, start to map all of this in a simple way. We are now mapping our activities to nouns, which is our resources, and verbs. So we have activities and we have resources. And so what we are going to do, is it post, is it get, is it delete, or based on the functionality? Let's see how it's very simple to do this. I create just mapping activities to resource lifecycle. So which should take discover actions to mapping actions to HTTP nouns and verb. And usually we have these: get, post, put, delete. I get a piece of paper or whiteboard and I create this table, and just only I have an item resource. What activity is list an item? What's verb noun mapping? It's get items. We use plural nouns here, items. This is very important to be consistent in naming. We don't use item because we always, when we say get items, without any documentation, I will understand that I'm trying to get all the items. And if I'd like to identify a specific item, like here, I would like to say that I would like a specific item from the items with this ID. This could be well understood that I'm trying to get single item resource because I have identified the ID. From these items, I need ID number 6 or customer number 6 or whatever. So this is how it's always get, yes, because I'm getting resources. And for the first list items, yes, it's the same URL. For view, it's the same, but I need to have more identification to get specific item. So I have to pass an ID. What about search? Search takes different approach. In the same URL, this is very important. I didn't develop like underscore search items. So I have different URL. So that you could end up, I have seen this when I was reviewing like code for people, and then they have like list underscore items, then they end up just for this table like with 5 URLs, different URLs. While here you can get out from this table, you can just end up with one URL with different parameters. So it's very easy for the customer, and it's very easy for your integrating party to memorize, and he knows. For consistency, yes, if I would like to get an item, I have to pass an ID. If I'd like to get whenever any kind of items or customers or orders, I have to just put the name in plural way. And the search, I will have to specify search parameter with exclamation mark, with question mark. And then if you'd like to add, just change the verb, post, because I'm adding, and it's the same. Then I have the body. And there is a question here, sometimes people ask me, because we have a limitation for the URL encoding, so up to 64 characters, sometimes they have search parameter, huge search parameter. In this way, you can use post in order to have, you can pass it in the body, because, or for security reasons, if you'd like to hash it, or because it contains some sensitive data or something, you can use post search. This is exceptional cases for just the way that you're doing search. And finally, if I would like to edit, which is put. If you try to develop, this is now we have a contract for item resource. And if you would like to develop something, for me, it's like easy. All the item activities will be around items. And then if I would like to get one item, it's ID. If I'd like to search, I will put a question mark and provide all the search parameters, and I can, if I would like to, the same URL using post, I will add new item, or with edit, I will edit the specific item with URL and just change the verb, and it's very easy to interact with. And then you can go, either you are using Swagger, for example, for your microservices, or if it's external customer and you don't like, we use Swagger mainly for internal developers. If we are doing microservices, and then we're trying to integrate, to make it easy for different microservices developers to integrate with us, so they have Swagger. If you would like to integrate it with external party, we can use ASCII Doctor for documentation, or Postman. Also, you can develop the API and use API exposure so people can interact with, or using your system for integration, or whatever it is. It's the tool is relevant to for whom you are exposing. This is very important. Why I need to identify participant, either they are external or internal, and also when to use which tool specifically for which part of the development. So I spent some time here to give you a lot of information, and easily I'm going to do the same job for the other resources. So let's go about the cart. Cart is somehow tricky a little bit. So what about the item? Why you didn't put, where is the mapping? Here we have a relationship, it's not direct, because I'm adding item to cards. It's very important to identify what is the relationship between item and cards. I'm going to speak about this in a while. Remove the item. So whenever it's another resource different than the original resource, like cart, I cannot map it, because I should identify the relationship first, because it's very important in order to develop our URL. And you see how. Okay, clear cart. Oh, I'm talking about cards. So clearing cart means delete this cart, because it doesn't have any meaning to leave the cart. It just to leave it, if I or make it empty, for example, because if you don't like it, clear it, delete it. So view cart, yes, I'm talking about the cart, so I can easily develop it, cards/ID. And then if I would like to check out, so check out, even it's different functionality. It's not the life cycle of the card. Is it a relationship, or this is a verb? It's check out the card. So let's see how we are going to develop. Let's go for different resource like orders. So if I would like to list an order, I will get specific order for the customer. So I will ask the customer for order ID, and I will get it. And then obtain order status. When I view the order, definitely the order will show its status. And for canceling, I will delete the order if I'd like to delete totally the order. And definitely for customers, if you'd like to search for customers, I will go for customers URL, and I provide search parameters. View customers, the same idea, adding customer using post/customers. And finally, if you'd like to edit, you will end up with each resource here with one URL. It's pretty simple and easy. Let's identify the relationship in order to complete our cart mapping actions. So identify these three actions. Let's see what is the kind of relationship. We have three here. We have independent, dependent, and association. This is very important. So independent, the resources may exist regardless of the other existing resources. So, but they may reference each other. The same concept here is the same like database. When you design foreign and primary keys and foreign keys, and either the relationship is a strong relationship or weak. So it means that this table cannot exist without the parent table, or it could exist like employee and department. They are existing regardless, because we have department physically and we have employees, but there is no dependency here. They are independent. But if you have dependent and employee, so if you have your family and employee table, the family does not exist in this company unless you exist. So this is called dependence. So this is and association. They just share more information when they are interacting to each other. We love movies. I know we love movies. We love characters. For myself, I admire Marvels. So this is why I would like to give you like one example about this kind of relationship to understand based on the movies. So there is a question to identify the relationship. Can the resource exist without one another? Does one resource only exist when the other exists? Or does the relationship between resources require more information just than the links? So let's see an example. For example, we have movies, and we can get a movie, we can get all the actors under the movie, and also I can know the characters in this movie. And also I can get a specific character. Nice. Also I can get the actors if I love this actor, like Captain America or something like this. And I would like to know about more movies because I'm a fan of this actor, and I would like to watch more movies or a specific movie. And I would like to see also different characters for this actor and different characters or specific character for this actor. But can you notice something here? That only at the beginning is movie and actors, and there is no character can be identified as a existing character or existing resource. Why? Because you will always have movies. It's a standalone. There is always a movie, and movie could be played by any actor. It doesn't matter. And the actor is a stand in his own, or her own. Why? Because they are actors and they can play many characters in different movies. So character cannot exist without movie to run inside or actor to play with. So this is very important. This is how I identify. This is what we call in our API sub-resource. So now the character should be sub-resource when we develop it. So the main resource will be movie and actors, and always sub-resource, because I cannot request a character in its own. I cannot. I should request a character based on movie or based on actor. So the main resource always in URL should be start with movie or actors. Did you get the idea? And for example, the second line, movie and actors, this is called independency, but the other I can get actors. I have it as a resource, and I have the movie. So this is independence association. This is the same relationship between item and card. So let's get back and develop this. Yes, we have cards, and we get specific card to add item inside this card. So I say cards/ID, and if I just didn't put any kind of items, I can say get items from the card. It will return for me all the items. If I specify the ID, it means get me the specific item under this card from the card, from the items already exist in this card. So for remove, it's the same URL. I just changed the verb. For checkout, I'm doing an action. So it could involve many like notification for here. When I check out means send an email with a summary of the activities to the customer, and also identify the delivery system, send another message for inventory, another message for payment system in order to take out the money. So this is action could be done, and each of what I have described now is just messaging system, and it should be in its own standalone. And when you notify like for payment or for address, it doesn't mean it should be an order. There is no order. You can identify this first, the second, the third. It just does one job, and it should be like this. So it's make it easy to make use of this API later and later in different composition. So now it comes like I have developed my API, URLs, everything. I would like just to validate. Are I okay with my API? Is it ready to expose and start developing the backend logic for this API? Before just I'm trying, while doing this, I'm documenting. You can see from the previous table, I already have documented my API, verbs, everything. And because of the presentation, I will not show the payload. I already have developed the payload to make it easy for people to just mock my API in order to mocking receiving response, and they expect this payload so they can develop their user interface, knowing which variables, names, and everything. So it's going to make it very easy for integration, and there is no integration problems in the future. Just they need to switch from the mocking to your URL, and everything should work by 99%. So validate. How do I validate? I write each resource action on node card. I did this before, and then use node card to map out each flow, action, etc. And finally, fill any gaps you might be missing, assigning them. So imagine that you get like a new requirement from the customer, or you have another requirement and you would like to see, is my API ready to serve this requirement or something new I need to introduce? So let's say that I would like to achieve these objectives, like handling missing order. What if I need to know about my missing order? And what if I would like to reorder the same order as last time? Can I do it with the current API? And finally, I would like to cancel part of an order, not the whole order. And it happens. So let's see. What I'm going to do is just review my current and see if my API could, in standalone call, can achieve this or not. For the first, if I would like to check my missing order, the customer service list the customer order. Yeah, I have an API to do this. Then the customer service obtain the customer order status. Yes, I have an API to do this. So I am fulfilling this requirement. Great. Let's move to the next one. The order, the same thing last time. First, customer view the previous order. Yeah, he can do it. So I have an API to do this. But customer copies new order, I don't have it. So I have to develop this. Customer checkouts, I already have it. So only I need to add a new API just to copy the last order to the new one. Part of my order missing, customer service list and orders, yes, they can do it. The customer service view the active orders, yes, they can see the status. And finally, customer service cancel a specific order. No, we don't have it. We can remove item from the cart, but we cannot play with order. So I have to add, remove a specific item from the specific order and to do the business project behind. Then at the beginning, you will see it as a big change, but finally I have to introduce only 2 API to satisfy the new requirement, because I have to break down again my activities and then map the resources. And then I found like I can do this, and go, this is the new thing. Okay, I'm going to my table, add a new requirement, and that's it. Update the document available for everyone, so everyone will take care of, make the changes. And at the end of the sprint, we are going to finally integrate and make sure that everything works fine. Go to the market, customer happy, get paid for your salary. In this pandemic situation, I hope so. To get money. So now we knew about, let's go to the technical part and what I need to understand from HTTP part and what to take care of and don't introduce. What is the pattern here and what are the best practices to use? Because sometimes there is some stuff that I see when I review code or consultant people that they're trying to create the same, like when you do exception handling. A lot of people creating exception from the scratch, while there is an exception and exceptions already defined in the GDK or whatever the language you use, and you can make use of it because all of us know about it. So it's very easy to catch it. It's the compiler is aware of it, and it's very easy for IDs to help you with. But if I found really that I need to define something specific to my business to do something else, yes, at that point I encourage you, yes, to create your documentation to be more clear than using the generic one, which will be not relevant at this point. So HTTP overview. So yes, it's a great tool because it's understood by the most clients and most tools out there. Entirely the web is using the HTTP. This is why REST is very famous. Either using GraphQL, which is based on HTTP, but have different concepts. If I have time, I'll give you just a small comparison between them, when to use what, because a lot of people say like GraphQL replacing HTTP as HTTP RESTful API. And no, we have this kind of argument always. No. There is always a need. We have always a problem. And when it comes to technology, we provide the solution that is specific for that problem. It's the same like everyone doing microservices as if monolith application is very bad. No, it's not a bad, but don't go with the trend. Just study your business, know what you would like to do is microservices, because microservices is just a small monolith application, but bring overhead of operation overhead, resources overhead, integration, a lot of stuff. You should know which design pattern really serve your business, because if you sometimes we run behind the technology, we will pay too much. I have joined a project that's really the company was doing a lot. They are smart to play with a lot of tools, because the architect was obsessed with all the tools, and the company bankruptcy, because they have a very high bill for the AWS, because there is a lot of resources running, DevOps, operation, which is many resources, and they pay like 60,000 per month euro for the bill just for AWS without going production even, just like the maintenance for many instances. For like, what? It's too much. So finally the company bankrupts. So it's totally different story. So we have to understand this. I'm sorry, I'm giving you my experience during I'm talking, because this speech, it's just the thought. It's combined, not just API design. It came from all of this kind of background. And by the way, REST is not a standard. We don't have a standard way. This is why we speak. We have to have a process. We have to standardize. It's not like soup. So REST is not a standard. And also REST is not a pretty URLs, just URLs. Necessarily, it could be XML or even JSON. It could be binary. It could be string fully. It could be gRPC and different things. So it's totally different. So don't deal with REST as it could be JSON. It should be URLs. No. It's not like this. It's a representation of the state of the information, and how we represent it. It's totally different. You could have even different payload definition than anyone else. It's based on your business. When you work, for example, with IoT, it's totally different from mobile. Mobile is mainly love JSON because it's very easy to consume and parse. For banks and for this information about banking system integration, sometimes they use XML over, because it could have a validation and security more than JSON. It depends on which kind of system you are dealing with, so you have the payload definition. So REST is a generally agreed upon set of principles and constraints. It's like soup versus REST. I can define in a simple, easy way. It's like mortgage versus borrowing $10. What does it mean? If you go for a mortgage for house, for example, you have to get some paper. You have to go to the bank, go through certain process in order to obtain the mortgage, and then you buy the house. But you have to go through a process. If one failed, you cannot continue. But REST, it's like, I'm giving you, hey, my friend, I'm giving you like $10. Yes, it's nice. But what if you bring it me back in 2 5s? And sometimes you give me 5 and you invite me for an ice cream. Or you invited me, if I'm a pretty girl, you invite me for a nice dinner, but with my money, which is not good, actually. You have to pay for the girl. So I'm joking. So it's a different way of returning the functionality, but finally I give you what you want. What you want, I give it to you, but in different way. But in soup, it should go through process. It's totally different. So this is that's how I can make a differentiation or comparison between soup and REST. And this is how you can understand it. So let's get back for HTTP. So HTTP well understood protocol, simple and powerful in its implementation. Yep, we know this. And we need to understand about the response and payload. This is what we would like to understand. Which part of the payload we would like to understand? In headers and response code. This is the most important. So all this information is hidden from the user, definitely, but not from the tools. So in order to access the payload, you have a lot of tools. I always use Postman or curl, definitely, and you have the freedom to choice. And what I would like to also emphasize here, I always need the most important, the content type, header status, and also media type. This is very important. Why? because the status, this is the response code of what you are trying to accomplish, either successful or fail. And based on this, what you are going to show to the user is relevant to the status you're returning back. The content type identifies the type of the payload being passed back by the server. And the media type, it describes the actual structure of the payload and how things works together. This is very important. So this is the main headers that I care about when I'm developing REST API. Unless there is something we like versioning, we could, because versioning could be URL based or inside the headers, you're passing versioning through headers or through the URLs. It's based on what you are accomplishing and how you design and how you expose your API. So HTTP response code, I'm caring only, and I have to care about 100s, not all the 100s, not all the 200s, not all the 300s or 400s or even 500s. Specific, which is in 100, I don't care about it. This is the categories, but I care about 200. So and this is the most 200 okay, 200 on, I mean created. So when we know this, it means it's a standard. It's a standard way so we can understand. If you go to any API, you will agree that 200 means okay, 201 created, 200 accepted, and 200 we're using for search when we would like to describe no content. Or using delete, for example, when we delete, okay, yes, we didn't create, we deleted, so we use no content. Or when we do change and just like update and we didn't change actually, so we say no content. So for 300, we are caring about 2, which is move permanently if you are trying to do maintenance or moving for some other services or some stuff, or you're moving your domain to different parts. And moving permanently is if you're trying to redirect to a new domain name, and permanently if you're doing maintenance or something happened with your servers and you'd like just to serve it from somewhere else, to just give information to the user. And 400, definitely we have 400 bad requests, and stick to these. And these HTTP response code just enough for all your development cases. As I told you, there is exceptions sometimes, and you try to search about the relevant, don't create another response code. And 4 or 3 for forbidden and security reasons and not found for searches. And this is what we use. Response code, as I told you, are great, but please do not create your own to not confuse your customer, because they don't expect it. Or they doesn't expect it. So now we should know about the final part of this presentation, which is the last 6 constraints we have to really put in our mind when we develop back-end API. Whatever your system is, whatever the language is either you're using JavaScript, Java, C#, any language that do web, and mostly you should take care of. This is like design patterns, and each API should satisfy this. So we should always design as a client server and stateless URL. It's the HTTP request. This is why we're using authorization OS2 and O0 authorization in order to avoid login and caching. And this is serve a lot of stuff. Cacheable if we can, as much as we can. Layered system. This is very important in order to add more functionality to the system. And we can, and this is the optional part. So you have to satisfy these 5 constraints. And code in demand is optional because we have argue about it, but I will show you when we can use it. And finally, and the most importantly, is uniform interface. Let's go through each of these individually. So client server is the same like web browser and web server. So they don't know each other. You're just requesting some names and then to get the functionality, and that's it. So they should not depend on each other. This is very important. By separating the 2, we can vary. Yes, you can move to different place, but just you have the same like DNS. Don't rely on IP. We have this problem with when I doing my job with working with database team or some security team. Like, hey, okay, here is our server. Then we give you your IP, and then you stick to the IP. and then you start to work, and suddenly your database is not accessed anymore, and you have trouble, or your whatever it is. You contact your database team. Oh man, we have just moved to another data center, or just we get down this server, and here is a new IP. Then I insist, no, create a name, DNS name, and just give me this name, and I will stick with it. Whatever they change, I don't care. I calling a name, and they shown the IP change. The same like the concept of Eureka, for example, the service discovery. I care about the service name. I don't care about the service IP and address or port or whatever it is. I don't care about this. So server, this definitely serves scalability and reliability. Yes, whenever you scale up, I don't care. I'm calling, load balancer can switch easily instead of the namings and everything. So this is the how you achieve client server when you do this. Try to not give your IP. Try always to give names, and try to be resilient. Stateless means you should develop always stateless API. Each request should stand in its own. Do you remember when we designed? When we break down, we should break the API to do one job at a time, and it doesn't depend on any URL, other URL. You can call it at any time in standalone in its own without any further information. You pass all the information, it do its job, and that's it. So this is how stateless API design and concept. It's the request can be processed in any order, because sometimes they will do. Yes, we should rely on this. Something like when you call Twilio, for example, and they would like, definitely for security, you have to have like, normally we have username and password, and you have your session, and you do session invalidation when it expires in 30 minutes or 1 hour or whatever it is. But how to do this with REST API? We use access tokens, which is you try to send every time with the URL in order to achieve the security, and you are not stateful. You are stateless still, because you have to give this security, and this validation, it does validate it every time, and this is how it works. So we achieve the security with stateless in this way, using access tokens. Stateless, why? Because it's flexibility. When you do more, so you are serving the customers, and you introduce the new instance. It's so flexible because each time you don't cache user information, so you don't have to migrate sessions from server to server in order to satisfy the system load indifference. So which means time to bring up the service, migration, bandwidth, it might fail. No. You always pass to the service, the access token, so it's always working. And scalability is very easy. You just spin up a new instance, and it works. It's added to the load balancer, and that's it. So it's very easy for flexible stability, definitely, because you don't have to worry about migration, as I told you, sessions, memory, and all of this kind of stuff, reliability. And because whenever there is no maintenance for data in the memory, means I'm reliable to do just only my business and system functionality. So this is about the stateless. Caching and cacheability. Sometimes we need caching, and it's very good to introduce caching in order to reduce the bandwidth, which is cost money in cloud nowadays, because sometimes you can get the bill very high, and you don't know why, even if your services does not work or something, but just because it consumed a lot of bandwidth, and you have to take care of this. So caching play a very significant part here. So each method should I describe whether it's cacheable or not. Improve network and application usage, definitely. It's not just response time, the cost also very important. Make the system more reliable and scalable. And sometimes you have to understand idempotent concept means whenever you try to get information, put information and delete, because idempotent means, or safe means, it could be cached. And sometimes we signal delete and put as idempotent means. I have developed this in my project, this concept in my project on GitHub, which is Springy Store. So idempotent means you will find in my API that whenever you call delete, Before, just when you call it, I don't wait for the response from the backend. I return back to you direct 200. I'm done, or 204. No content changed. Even I send a message and I don't know when this message should be consumed and affect the system by deleting or whatever it is. But I don't put them because it's finally is going to be deleted. And if I apply the delete many times, it will not affect the system because either the resource is deleted or is going to be deleted. So applying the functionality more than once, it will not affect the system. This is why get the same. If you get the resource and try to call get 100 times, it will get the same resource. It does not make any change to the system. And the same put will change the first, then whenever you try to update the same content again 100, it does not make any change to the system. This is why it's called idempotent. But we cannot do this with posts, because whenever you call post, you create a new resource. So you cannot cache it. This is the most important. You can cache get, put after the first call. For putting, you can call it if the same parameters, so you can cache it normally, and delete is the same, and get is the same. But post, you always create new content. You're always creating new content, so you cannot cache it. So you have to understand this concept very well. So e-tags means this is built in for caching signaling, and generated for individual requests sent in headers, and it compares to see if anything had changed or not to serve from cache or get the resource back from the backend. So available via header verb, and you can read more about it. And here's an example about how it gets. So you can the third line e-tags and give you like hash, and this hash represent either is the content has been changed or not in order to serve from the cache or from the backend. The risk constraint, let's talk about layered systems, finally, code on demand, and the most important, and this is the final part. So layered system, we deal with this. So don't count on the client interacting directly with the server, as I told you before. We use this on the web every single day. And also it adds silent, invisible dependency. Why? Because it allows in between system to add and remove functionality. So we do this with like, if you would like to add the compression functionality, security, logging, we can add filters between the client and the server backend without any kind of interaction, because without any kind of notification that or downtime or something. I just can add it and it will work seamlessly without any kind of customer affection, because it's, and I can remove it too at any time. So this is why we build the system layer. And the same, like when you build system layers, like means when it comes to backend also, the model part is totally different from the services, totally different from the repository, totally different from the database or integration part. Because any part of this, if there is something changed, it shouldn't affect the different module. And this is how layered system. It's coming from the API design and until the backend system. This is why I called you like design is not an easy thing to do. It's hard, but when you do it really in a correct way, you would save a lot of time when you are maintaining your system and application and respond to the new business functionalities. And as I told you, it allows load balancer, caches, logging, authorization, etc., to be just merged in, between or among these kind of client and server, and you can remove it at any time. It's easy monitoring, whatever you would like to add. And let's now, code in demand is the nightmare debate between people, because the request does not just retrieve the request, but sometimes the code that acts upon it. Wow, you're injecting code into my application means security. Yeah, we don't have to know about to understand the code, just how to run it. Who did this? Believe me, it's already exists. But this is allow flexibility and upgradability. I know that executing third-party code is security nightmare, but sometimes you have it in the famous Gmail do this. You just refresh your API, you have a new functionality, new buttons, new interface, and all the code that act on this kind of a new functionality already installed in your machine as a JavaScript, and it runs normally without any kind of upgrading or doing or reinstalling or something. So this is how it works. And finally, let's talk about uniform interfaces, which is I just described when we do tabling for the resource names, the combination to relationship and everything. But let's show that this should be present in every API. This is very important. It's the most complex, but most powerful at all, as I told you from the beginning. So we have three principles here: identification of the request, manipulation of the resources through these representations, self-descriptive messages, and finally, hypermedia as an engine of the application state, HATIS. Let's explain each of these in its own. Identification of the request means I can, from just your general agreed on principle, generally we use noun, then ID to bring like nouns, plural nouns. Then if I like to get just only one, as I told you, we identified by its ID. And if we have actions like checkout or another item, we can do nouns, actions, ID. But we don't do nouns equal whatever. It's combination of things that you use. It will confuse your customer, because we have agreed on some principle and naming stuff, and then we should follow this general agreed upon resource name. Manipulation of the resources through this representation means something like this. We have to reduce the number of API calls, and it will be very easy. For example, Twilio, if we take Twilio, for example, this is all the combination. So they have, based on the year, they have accounts, and each account have account SSID, which is represent who you are, alongside with the authorization token, and then they have calls, records, and SMS. Can you see that they are plural? So from accounts, account SID identify your single account from these accounts, and then I would like to get the calls for this account, and or I would like to get a specific call from the calls of that account. The same happens for recordings, the same happens for SMS. So if you would like to sum up all of this API call, you can just summarize it in one single node that say get. We use get for all, so you can get records, get calls, get SMSs. We only use post for calls and SMSs. It makes sense. We don't change anything because you cannot change calls, recording, or SMSs. It's static. And we delete only recordings because calls is just a history without any code. That's it. This is API, and all the functionality has been served using these just only API. So it's self-descriptive. So this is how we manipulate. Self-descriptive message means each message should tell if that resource is cacheable, how to process itself, how to request the next resource. And finally, HATIS means client always interact with the network application entirely through hypermedia provided dynamically by the application servers. So when you call a server, you expect to get some payload, but it's hidden from you. You don't know what they could present next, what functionality need to be done, especially in banking system. I will give you an example. So you have to serve your customer with some information how to interact on this account. How I can, for example, if I'm asking about my account from the bank, for example, I would like to get my account from a specific bank, I should receive something like this. So here is your account, here is your balance, here is your currency, but also you can do deposit, and I give you href for each functionality automatically. This is what we call HATIS. So you only need to assign this URLs to just buttons, and then take some parameters in order to, for example, deposit would like to deposit some money, withdraw you would like to withdraw, could be used for ATM machines, transfer, you could transfer it from your account to different account, or you close your account. So you have the functionality at your disposal. If the bank really try to expose another functionality, you will expect another link will be returned so you know about the functionality. If I created a resource, for example, I created an account or I created a user, the response should say, yes, you have created the user with this number and you can view this user, you can edit this user and give you the full URL. So you can easily navigate through all the functionality without kind of guessing or trying to build it yourself, and with the correct names and everything. This is really way powerful to serve your customer and show them that you have introduced new functionality and enhancement. And whenever you do changes, also you expose these changes very quickly, and instead of calling the customer, please consult the documentation in order to see the new change and to view my changes in order to apply to your system. It will be at the hand of the developers at the same time. So imagine that you are dealing with and assigning href to your buttons, and something had changed in the back end, and then you still referencing the new change without changing your code. It's nice, right? So you achieve the same functionality, but the URL changed, but the same parameter. I don't care because you already return it for me, all the URL that you need to interact with, and I assign this URL to buttons. Whenever you change it, I don't care, I will call it, and that's it. So if, for example, if you call GitHub API, you will get all the payload like this. So they give you like, here is the key, and here is the API to call. So you just looking at this payload, you will understand really what I can do and what I can submit and how I can build like a client around my API, my API for my GitHub APIs, and interacting directly or developing a client application that interact with GitHub without studying too much for the documentation. Then if I don't understand a specific one, I can go to the documentation to read more for security or some certain reasons. So it's very easy to grasp your business and to integrate with more easier. Whenever you reduce a step for the integrator for you to integrate with you easily, you are the winner here. What I can say here, this was our journey for the API design, and I can say that we reached our goal by explaining how we effectively could design RESTful API, how we can model it, design it. We have consistent process. Documentation is very important. I'm just using paper-based in order to develop my application. Use the tool, whatever relevant to you. You don't have to stick a tool. I would make it easy just to write down. And then we considered HTTP in order to develop and really have a good documented APIs for others to integrate with the correct HTTP codes, payloads, URLs, verbs, action, everything is each part. And then when I go back to the back end, I know how to develop my systems in order to achieve the 6 constraints we have demonstrated here. So I hope that you really enjoyed it. And thank you very much for your participation. And I don't know if we have some time. Oh, I almost take more time. I'm sorry for the next speaker. And you can reach me on...
Hello, everyone. Good morning, good afternoon, good night, wherever you are. So, hello, Mohamed.
Hi, I'm very sorry to take from your time. Because...
Yeah, no, that's okay. We had an issue with the next speaker, so that was okay with that. So we can move to the Q&A.
If there is that's then you are welcome.
Yeah, so hi, Mohamed. Nice to meet you. It was a really great talk. I learned a lot about REST, APIs, and so on and so forth. Let me start to the Q&A here. I'm going to ask the question that was the most upvoted one. Is there any specific design strategy for event-driven APIs that you might consider?
This is another event-driven API I'm using. I have also introduced this in my GitHub project, which is Springy Store, because I try to show the concepts of the design. So we have asynchronous or like reactive programming design, and when we can use this, and also because there is confusion always between event-driven, and it should be combined with reactive. They are totally different. So reactive, when we need to satisfy many requests, loads from your server, and messaging, if I don't care about the response, like I do messaging, for example, for delete and updates. But when it comes to Git, I use synchronous API. So, so whenever I design for this, yes, because the customer does not have to wait in order to get response, and this is also achieved. I don't important concept, because you would like to delete a resource, it will return for you. Okay, when you try to get it, it does not exist. So I'm just speeding up the way that I serve the customer in order to not queue the system. So I use messaging server and leaving to the other systems or microservices a way to process the request in any order they would like, and make the microservices not dependent. They are independent on each other.
Oh, nice. Right. So the next question is, how does the programming model we choose, depending on if we're using DDD, event-driven, event source, affect on which API design strategy to use? Do you see that as
again? DDD.
Yeah. Go on.
Can you repeat the question again?
How does the programming model we choose, DDD, event-driven, event source, affect on each API design strategy we use?
It does not affect the design, but when you start using TDD, let's talk about TDD, because event sourcing and this kind of stuff is just a way that we consume another API or have, because when you deal with microservices and event source or event source, yes, but when you talk about event-driven, you are consuming messages from queues, so it does not make any call for the API. This is one thing. For event source, yes, you are calling API, but doesn't mean, if you really stick to design your API to be standalone, stateless, and it could run in any order, you will highly achieve your business requirement from all your API. And whenever you have a reply or like forward processing, you like to do some actions, you can call any API at certain time. It shouldn't go always in the same process. Like if I have 3 API and I need some action and I failed in the second, I can start from the third or fourth. So it doesn't have to be back, because they are not dependent on each other. Each one of them, like standalone, have their own information, and that's it. So you can use it for event sourcing. When it comes to TDD, TDD is a very powerful tool because it's different concept from these other tools. I have written an article about this for Java Magazine and InfoQ. You can read about it. TDD, I love TDD because it represents my customer. TDD for me, when I start to develop first the call for my API, and you'll find also this kind of TDD design in my project. I encourage you to go at Spring Boot. I intend to develop TDD first because it makes me change and sense how I develop the API, how it's hard when I call it. Because when you start design first, you just have your design, I need this information and everything. When you start to use your API, it's totally different because you start to make sense of the customer now. You put yourself in the customer's shoes and you start to use their way of integrating. So you figure, oh, it's very hard. I have to add all of this information. Why I didn't reduce it? Then you change your API to satisfy this. This is what you get from TDD. And even it's not just about the API, about everything in your coding.
Okay, one last question. It's from Andreas. He says, delete is normally used when to define a deleting records, but what happened when you have just a partial delete? Should we use? Is better to use put or patch instead of it?
So again, the question, because
delete is normally used to define deleting records, but if you wanted to have just a partial delete, like change from active to deleted, he gave that example. It's better to use put or patch instead.
Yes, because whenever you change the status of existing record, you don't use delete. Because in this way, when we change active to inactive, it's called logical delete. It's not physical delete. So, if your business always, because I now maybe I will catch his mind, Andrew's mind, because he says, okay, we do logical delete, it's not physical, but it represents as if deleted. So you can use if all your business running like this, or if you intended to change the status only, but the record will be shown, use put. We use batch only for bulk edits or bulk add. So we don't use batch for single edit or something. We use batch with bulk edit or bulk delete or add. But for delete, you can use it if you always your delete means logical, and you need just to not confuse the customer. Okay, just when you delete logical in the system, but make sure that this record does not show when you call get. But if you would like to change the status, you can use bot normally.
Right.
Because it changes.
So I have a really, I mean, this is going to be a really tough question. Is there a situation when it's better to go with SOAP instead of REST, or has REST fully replaced by, has SOAP fully replaced by REST?
No, it's replacement, because when it comes, I was working for financial services and integration, and sometimes even the business will demand that you have to integrate SOAP-based. Because of the security, the encryption, we could achieve all of this using REST, but based on the business, they use the integration from system to system. You would find SOAP easily could be used in this part, and because of the systems. But when we would like to introduce our services, sometimes you have SOAP for some integration, and you have REST for mobiles, for IoT, for all of these kind of things you can integrate with. So you can have two interfaces even. And sometimes we could achieve with REST the SOAP functionality, little bit. But SOAP needs like specific headers, specific bodies, specific constraints. But REST is more flexible. But I can give you the bunch of XML as a representation, secured, signed, and everything. Then you can exchange. But it's easy to introduce many channels. There is no replacement, because there is a lot of systems that you have to integrate with SOAP based. Security reasons, or they don't like to change because they don't represent the systems for example, for mobile, for different kind of application like Facebook and Twitter, they have to have and to use REST. But when you call their API, you will find that they could return XML, custom API, and also JSON based. So they have the three representations, and whenever you would like to consume, you can use.
Okay, nice. That was a really good Q&A. Somebody was asking about your blog link on chat. If you have a blog link, you can share. Also, there is one question about books. If you have any,
here it is. You can take screenshots of these. Okay.
Right.
And also, in Twitter, ping me at any time, or even open issues to my Spring. There is a lot of people opening issues. It had like 200 followers and stars. So people open issues because they're trying to learn, asking things. We add functionality. If you'd like to add, to learn from it, I developed it because I would like to clarify a lot of stuff. You will find Kafka integrations, message-driven, TDD, all the cloud-native stuff, doing microservices, event-driven, reactive programming, security, and then I'm trying to develop it to be Kubernetes and it Dockerized. I'm using Java 15 latest version also in order to catching the latest technology. So you are welcome to participate, welcome to learn. I love to share. Ping me at any time. Follow me on Twitter, and you are welcome for any question you would like.
Okay, thanks. That was great, Mohamed.
Thank you very much. And I hope that attendees get benefit from this talk. And if this is on Prezi, you can get back to this presentation at any time.
All right.
Okay. Thank you very much.
See you.
I will go off now because the next speaker